matter can be classified as pure substances and mixtures. A mixture is a combination of two or more substances that are not chemically the same and do not react with each other. Its properties are same as that of its components. For example, a mixture of sugar and sand will have the same properties of both sugar and sand, and they can be separated by physical means. In a mixture, the components can be present in any proportion. It will not make a difference if you add more sugar or sand to this mixture. Consider a solution of salt and water and soil. Both are mixtures, but in the first case you cannot differentiate, whereas you can separate different types of particles in a soil. Soil is a heterogeneous mixture where the composition of particles is non-uniform and one can easily differentiate them. Salt solution is a homogeneous mixture where different types of particles are uniformly distributed. Cereal in milk, ice in soda, blood, soil are examples of heterogeneous mixtures. And bronze, steel, air, rain are examples of homogeneous mixtures. Solution is a homogeneous mixture of two or more substances. For example, lemonade, soda water, etc. The component that is present in large amount is called a solvent, and the component that dissolves in the solvent is called the solute. For example, in salt water, salt is the solute and water is the solvent. There are different types of solutions. Solid in liquid solution, example salt in water. Liquid in liquid solution, example vinegar in water. Gas in liquid solution, example soda water. Alloys are mixtures of two or more metals, or a metal and a non-metal. Example bronze. It is 30% zinc and 70% copper. It shows properties of both copper and zinc. Alloys are homogeneous mixtures and sometimes referred as solid solutions. Properties of solution. Solutions are homogeneous mixtures. The size of particles of solute in a solution are smaller than 1 nanometer. They do not scatter a beam of light, and the solute particles cannot be separated from the mixture by the process of filtration. A suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended. Their properties are: it's a heterogeneous mixture, the particles can be seen by naked eye, the particles scatter beam of light, and the solute particles settle down when left undisturbed, and they can be separated by filtration. Where can we see the path of light through air? Because air is a mixture that contains dust particles dispersed throughout. These dust particles disperse light. This phenomenon is called Tyndall effect, and such mixtures are called colloids. Colloid, like suspension, is a heterogeneous mixture, but the particles are so small that they are invisible to the naked eye. They scatter beam of light and cannot be separated by filtration. We need to use a process called centrifugation. Take a solution of salt water and boil it. What happens? Water will evaporate and we will be left with salt. This is how salt is produced from seawater. This process of separation is called evaporation. It is used whenever there is a volatile solvent and a non-volatile solute. Volatile means one that can evaporate easily. Centrifugation is a process in which heavy particles are separated from lighter particles when the mixture is placed in a centrifuge as shown in the illustration. The heavy particles settle at the bottom. It is used for blood and urine tests. It is also used to separate butter from cream. It is also used in washing machine to squeeze out water in your dryers. When we have two liquids of different densities which do not mix, we use a separating funnel. When you put the mixture in the funnel and leave it for some time undisturbed, the heavier liquid will settle down and can be separated out. It is used in extraction of oil from water and iron from its ore. If your mixture contains a component that sublimes, you just have to heat it and the non-sublimable components are left behind. For example, if you have a mixture of ammonium chloride and salt, on heating, ammonium chloride will get converted into gas and the salt will be left behind. When multiple solutes are present in a solvent and have different solubility, we use chromatography. When you dip a filter paper in a solution containing these solutes, the more soluble ones move faster, so they can be separated from the rest. This is used to separate colors in a dye, pigments for natural colors, and drugs from blood. We have already learned how to separate liquids that don't mix. But what if they do mix? If they have different boiling points, we can use distillation. Here we heat the mixture and the one with lower boiling point evaporates first. It is cooled and then collected in a different vessel. For example, a mixture of acetone and water. Acetone has lower boiling point which boils first and gets collected in a different vessel. But for distillation, the difference in boiling points should be at least 25 Kelvin. Otherwise, it will not be effective. Fractional distillation is just like simple distillation with a fractionating column which helps separate mixtures of liquids with closer boiling points. Fractional distillation is used to separate different constituents of air. The boiling point of oxygen, argon and nitrogen are -183, -186 and -196 degrees Celsius respectively. We can see that they are very close and all of them are gases. So we initially compress them and convert to liquids and then use fractional distillation. Fractional distillation is also used to separate different components of crude oil like petrol and diesel. Some solids, when in solution, crystallize after a while. This process is called crystallization. It has some advantages over evaporation. In evaporation, some solids decompose on heating. Sugar gets charred. Some impurities that are dissolved in the solution remain with the solute after evaporation. One can overcome these disadvantages of evaporation using crystallization. Uses purification of salt that we get from the sea. Separation of crystals of alum from its impurities. In a physical change, no new type of particle is formed. If an ice cream melts, it is still ice cream. In a chemical change, the whole basic composition of the substance changes. When wood burns, you get carbon which is totally different from wood. The following are the main differences between physical and chemical changes. Physical changes can usually be reversed. Chemical changes cannot be reversed. No new substance is formed in a physical change, but in a chemical change, new substance is formed. Consider burning of a candle. It has many changes happening. The melting of wax and resolidification is a physical change. But wax burning and producing carbon dioxide and water is a chemical change. Elements are substances that cannot be broken down into simpler substances through chemical reaction. Example, gold, silver, sulfur. Whereas compounds are formed by chemical combination of two or more elements. Example, water, which is formed by the combination of hydrogen and oxygen, and methane, which is formed by the combination of carbon and hydrogen. As you can see in the illustration, in an element, all the constituent particles are the same. In a compound, the constituent particles are made of two or more different types of particles. Elements can further be classified as metals, non-metals, and metalloids. The differences between them: a metal shines, a non-metal doesn't shine. Metals conduct heat and electricity, while non-metals do not conduct heat or electricity. Metals are malleable and ductile, while non-metals are non-malleable and ductile. Metals are sonorous, that is, they produce sound, and non-metals do not produce sound or they are not sonorous. Few examples of metals are gold and silver, and few examples for non-metals are graphite and oxygen. Some elements have intermediate properties between metals and non-metals. They are called metalloids. Boron, silicon, and germanium are the examples for metalloids.